Here's an equation simple enough for a child to write down. Z to the 5th power equals 1. It asks a plain question, what number multiplied by itself 5 times gives you 1? And it has exactly 5 answers. That's the whole thing, nothing intimidating. And yet, buried inside the search for those 5 answers is one of the most intricate, infinitely detailed objects in all of mathematics, a fractal. It is hiding in there right now. Today, I'm going to show you exactly where it lives, and why almost every equation you have ever seen is hiding one too. Start with a harder question than what are the answers, how do you actually find them? For the simplest equations you have a formula. The quadratic formula solves anything with a square in it. There are uglier formulas for cubics and quartics, but for most equations there is no formula at all, no clean recipe that hands you the answer. So mathematicians do something more human. They guess, and then they get less wrong. Over and over, until the guess is so close, it might as well be the answer. The most famous way to do exactly that is called Newton's method. The idea is beautiful. You want to find where a curve crosses 0. Pick any starting guess at all. Draw the tangent line, the curve's own slope right at that point, and slide down it to where that line hits 0. That is your new better guess. Now repeat. Each step the tangent quietly points you closer to a true crossing, and in just a handful of steps, a wild guess collapses onto an exact solution. It is a little machine for turning, I have no idea, into there it is. But the answers to our equation aren't ordinary numbers sitting on a line. They are complex numbers, and they live on a two-dimensional plane. Left and right is the ordinary numbers, up and down is the imaginary ones. The 5 solutions sit spaced evenly around a circle, like the points of a star. And Newton's method still works here, except now it isn't sliding along a line. It is a little engine that takes any point on the whole plane and walks it, step by step, toward one of those 5 stars. So let's ask one simple question of every point on the plane at once. Drop a marker anywhere you like, run Newton's method, and watch which of the 5 routes it finally arrives at. Then color that starting spot to match its destination. Points that fall toward the top route turn violet. Points that fall toward another turn cyan. Do this for every point on the plane, and the whole thing divides into 5 territories, 5 basins, each one the collection of every place that flows to the same answer. Now here is the question that cracks the whole thing open. What happens at the borders, the places where one territory meets another? Your intuition says, a clean line, violet on this side, cyan on that side, a tidy fence between them. That is how maps work. That is how any sensible thing divides up space. Hold on to that expectation for exactly one more moment. Because it is completely wrong. Zoom into any boundary and there is no clean line anywhere. There is a storm, an infinitely intricate, curling, budding lacework, and here is the impossible part. At every single point along it, not 2 but all 5 colors meet. Every route has territory pressing right up against every boundary point, no matter how far down you zoom. The fence between 2 countries turns out to contain all 5 countries at once, forever, at every scale. How can that possibly be? Think about what a boundary point really is. It is a place so perfectly balanced between destinations that the tiniest nudge, a millionth of an inch, flings it to a completely different route. Its fate is undecided in the most violent way imaginable. Push it a hair one direction, it ends up violet, a hair the other amber. That infinite sensitivity, where the smallest possible change completely flips the outcome, has a name. It is chaos. And the set of all these perfectly torn points is a fractal. This boundary has a name of its own too. It is called a Julia set, after Gaston Julia, who studied these objects in 1918 with nothing but pen and paper, decades before any machine on Earth could draw one. He was reasoning about the shape of chaos itself, completely sight unseen. What we are rendering here in full color is the thing he could only hold in his head, the exact frontier where Newton's simple, orderly rule tips over into something wild. and it never once simplifies. Zoom in on one of the little buds along the boundary, and tucked inside it is a smaller copy of the entire five-fold flower. Zoom into that, and there it is again. Infinite detail, self-similar at every magnification, all of it forced into being by 5 tiny words. Z to the 5th equals 1. The equation didn't just have 5 answers. It had a whole hidden universe wrapped around the question of how to find them. Sit with what this actually means. Newton's method is completely deterministic. There is no randomness anywhere in it, and the same starting point always traces the same path. And yet, on the boundary, it is utterly unpredictable because you can never pin down your starting point precisely enough to know where it will land. Perfect determinism and total unpredictability living inside the very same object. That is the deep shock of chaos, and it is not some rare exception. It is woven into the simplest arithmetic there is. And none of this is special to our little star-shaped equation. Take any polynomial at all, any equation built from powers of a variable, run Newton's method on it, and it grows its own fractal, its own Julia set, its own storm along the borders of its basins. The fractal is not a rare specimen you have to go hunting for. It is the generic, unavoidable shape of what solving an equation actually looks like, whenever you have to chase the answer instead of being handed a formula. And there is a reason that chase matters so much for this particular equation. That innocent 5th power is exactly where the formulas run out. There is no general formula, no arrangement of roots and radicals that can solve every 5th degree equation. It was proven flatly impossible almost 2 centuries ago. So for the quintic, iteration is not a shortcut. It is the only road there is. This fractal is not decoration laid on top of the mathematics. It is what solving looks like, in a place where a formula simply cannot exist. So here is the whole story. An equation a child could write. No formula, so you guess and improve. That's Newton's method. Carried onto the complex plane, it carves the world into basins, one for each answer. And right where those basins meet, order dissolves into an infinitely deep, chaotic fractal, a Julia set that hides a perfect copy of itself at every scale, and hides inside very nearly every equation ever written. Simple rules, infinite structure. Chaos at the razor's edge of order. Everything you just watched was real mathematics, Newton's method, iterated across the complex plane straight from the equations themselves. No effects, no invention. The fractals were always there, we only colored them in. If you like finding infinity hiding inside something simple, stay a while, there is so much more of it. This is chaos canvas. There's a lot more order and a lot more beautiful chaos hiding in the noise.